Hi, this is a Chinese-made battery that I bought something like 5 or 6 years ago. I managed to operate my laptop with 18 volts from this one. It's pretty nice. It was pretty nice, but after about 2 years, it stopped working. I put it aside and didn't know what to do with it, and gradually I opened it, at steps. And after just a little peek inside, after a few months, maybe 6 months, look more, think about it. And over the years, I eventually came to the state that I took this cell out. Now, the cell that I took out didn't have this masking tape. It was connected, and especially it didn't have this wire. This is something, this tape and the wire are something I added lately. Now, I measured the voltages on each cell, to put it shortly, and they all measure below 1.5 volts, which is way low from the 3.7 nominal, or as the usual voltage that such cells are meant to have. And my goal is to bring each cell to capacity to measure 3 volts, and then I plan to reconnect it to the PCB of the Chinese battery, and let the controller, which is here by the way, let it work, do its job, and hopefully everything will work normally. Now, I am not a professional electrician, and I don't have a lot of experience and knowledge with electronics, so everything I will say in this video is, should be taken cautiously. Don't follow this blindly. And of course, I hope to upload a video later of the results of my plan, which of course I'm going to elaborate and explain in details in this video. Okay, so let us concentrate on this battery and understand it better. You can disregard the masking tape and this wire because they are a late addition that I added last week. This orange tape is called the Kapton tape. It is heat resistant and isolates electricity. I carefully peeled the Kapton tape and exposed this small PCB. I immediately marked the wires for future reference. I measured voltages between adjacent contact points, and all of them actually. I created a table and traced the wires and the construction to trying to understand what is going on. I had no idea. It was the first time that I was dealing with such a battery. This is the marking in very small letters at the bottom of the PCB. I couldn't find this small board with Google, and the chip is a controller chip, which basically means that it is this small PCB is a charger, because it takes over. It is responsible for all the functions of overcharging, over discharge, undercharging or discharging, everything that has to do with charging a LiPo cell. On the other side, we have 4 MOSFETs, which are responsible for the current control, and And then I found out that also this structure of the battery is called 4S, meaning 4 batteries, 4 cells in series. There is also important something to consider. It is the overheating and possible fire of a cell. The charge should be has a range between 5 and 45 degrees Celsius. If the cell overheats, then it damages its ability to store charge, and short, if it happens, maybe the cell is punctured or whatever, or the leads. A short is zero resistance and maximum current and maximum power and maximum heat in a very short time. The cell will first expand, puff, and then it will emit smoke, and then it might catch fire. And this fire is chemical. It is the reaction between the lithium and oxygen. It cannot be put away with fire. So it is very dangerous, something that I have to keep in mind and use precautions against. Okay, so I went online and I saw videos and Googled, and every LiPo battery has 2 sets of wires coming out of it, the mains and this one with many thinner wire that actually they mimic what is already on this battery by the small wires here. This means that the chip can access each cell separately because there are 2 wires always on each cell, but they change their relative name. So this is the first is the black wire is the minus, and this wire to the joint here is the plus, but this same wire is considered the minus of this cell. Now they all have on YouTube, they all have chargers, specific chargers for LiPo, and these chargers use both wires. And they have 3 stages. The first stage, first of all, they will not start charging if the value of the cell is below 2.9 volts. Then they would charge with the constant current up to 4.1 or something like this, and then they will go into a state of called balancing, which means that they work to equalize all the charge in each cell in the battery they are charging. And after they reach the set value of 4.2 volts, they go into constant voltage state, which they just keep the voltage at 4.20. This wire, I saw some people, they use it to directly access and charge a cell. And this is what I will do. Now, what I need is 4.2 volts, and I plan on 0.1 ampere, 100 milliampere, and I have to fill each cell to 3 volts. And then reconnect it, and the charging circuit, this and the battery and the Chinese battery will take over. This is trickle charging. The current, I will have to keep a constant current as the charge is going up. Now, chargers, when charging, there is a term called C rating, which means taking the milliampere hour of a cell and translating it to the charging current. For example, 600 milliampere hour would be translated into 600 milliampere current of charge. This is 1C. If it would be 2C, it would be double the current, etc. But this is irrelevant because first, I don't have a charger, and second, I'm going to charge, I need to charge at a trickle rate of 100 milliamp per hour with a voltage of 4.2 volts and to fill each cell to bring it to 3 volts. And now the way to do it is by limiting the current with the resistance, and in my situation it should be a variable resistance, since it would probably change as the cell is filling up. So this will need to keep in an eye on the current and adapting it with the variable resistor or potentiometer. I discussed with a friend the possibility of using the variable resistor in parallel to the battery, but it doesn't solve the main issue that I have, is that of the starting current that will happen when I initially start charging, and then so I will have to adapt the current live, and then keep adapting it as things go and the battery fills. And yeah, so there is no point in complicating the circuit that I will have to use. And these are Ohm's law. The calculations are pretty simple, straightforward, and at 4.2 volts and 0.1 ampere, the resistance should be above 40 ohm, and the power will be below half watt, which is very nice, and shouldn't cause any issues of heating up. Okay, so now we move to the plan and design and etc. First, I considered charging each cell from the PCB, but it is too risky because risk of a short, and it's a small place to work with. So I had to find the proper cable and wires. So, and luckily for me, I found this connector with the 5 wires, thin wires, which every one of them is colored, and this is very important. And then I had to solder them to the joints on the battery. Now, how I did it is, so I carefully cut an L-shaped cut just above the soldered point where the wire is soldered. It is usually soldered with relatively a lot of solder. So it is easy to cut. There is no less risk of cutting the coating of the cell. And then I peeled this cut to the side, taped it to the side, and I could access with the solder quite easily. Now, when I soldered, I did it for a very brief time. I didn't heat it. I didn't want to melt the whole of the solder, so just enough to connect the wires, to solder the wires. Now, the color scheme, the way they are ordered with the colors is very important, and they must be connected like this, because we will be using a pair of wires, adjacent wires. So if the first one is black, must go here, and the orange one is the second. It should go here. The green is the third. It should go here, and actually it does. So this is doing this, I created the balancing wire that every LiPo battery has. Then I had to create a wire to connect to each cell, to each pair of the connector. What I did, where is it? Okay. I took from an old motherboard the jumpers that were on board, soldered them out, and cut two soldered wires, and created this wire that will be used for trickle charging. Now, it is very important to keep the colors right, because if we connect them with the opposite polarity, it's very bad, okay? It's like a short, so it's not good. So we must keep the polarity on all the system correct. Now, I will have to, how do you say it? I will have to measure the voltage and the current. Now, the way to do it, this is the cable that I will use, and this here is the ampere connector for measuring the current. I used this Molex because I have a multimeter with leads. Just a minute. These leads just go very nicely inside here, and it's very a nice connector for this purpose. Now this, I just had this connector and used the two nails. I soldered them, and yeah, so I can use it like this. I will use it. As you see, I marked the colors so that there will be no mistake. Now, this connector, the voltage goes to the plus and the minus. So it is connected like this. It will be connected like this. And the power from will be, go into this wire like this. So we have a black here and red here. Because this is also a Molex. Okay, now I didn't use a special connector because I didn't want to mess up things. I wanted a design that is easy to disconnect quickly. And I cut the plastic coating not in parallel and not here. So this in this situation we can have a short, but in this situation there won't be any short. I still have to connect these two wires and make sure the connection is still good. Just a minute. So yeah, this is basically ready. I will be testing it just before I charge. Now, I don't, as I said, I don't have a charger, but I have a buck converter, DC to DC buck converter, and I happen to have this 18 volts 2 ampere charger, and I have this connector which fits nicely. So it will work nicely. This exposed just a minute. This exposed pin will not have. It does not have electricity in it. It's for a laptop battery, so it's irrelevant. Then this is the pots that variable resistor that I'm going to use. I have a small one, but it's a bit tricky to adapt live. I might need a quick response. So this one is good enough. If I have the multimeter connected and I know the actual current that is going on, I have to mark the direction of turning the knob, so that I don't by mistake go under 40 ohm or near the zero. I need to increase, always go up. Okay, I had the battery went down on me, so I'm here now. This potentiometer has to be pushed away from the zero, and I have to mark it. I might do it a bit later. I took the leads from some beefy resistor, a big resistor that I have, and I solder them here in such a way that I can connect the wires in a manner that is safe. For example, like this. Okay, and I also have to put some isolation on the third leg, but I'll do it later. This here, this is just a wire copper wire, just to be able to, when I remove, if I have to remove the connection, the crocodile, I can put it like this and it doesn't move around. It has a place to hang to. This one too. I added the LED with the 150 ohm resistor. It should be good enough on all settings that I will use the multi-variable resistor, the pots. And I think this is it. This is a DC to DC buck converter, and I have I made a few years ago. I made this one, which has a display, but I don't want to risk it in this project. This is just a foam that had this room inside that I can fit the converter nicely. And yeah, this is just a minute. It's not like this. It should be go like this, black to black, and red to red, red to red, and this connector will go into one of the two of the inputs in this connector. By the way, this connector from the motherboard, these jumpers are in the right distance from one another. It seems to be a standard, so it fits perfectly inside, but not when I want to use it. This is epoxy glue. So everything is nice, and just a few minor things that I have to take care of. Maybe I will do it now. I'm not sure. Yeah, I'll see. Maybe I will edit. I don't know. Just a minute. Okay, so I actually arranged a live test in order to set to mark the place on the potentiometer where the turn increases the resistance. And I decided to use the actual things that I am going to use, the power supply, the buck converter, the cable. Here the ampere measurement is connected, and the colors are as expected, and here too, black to black, red to red. And here it is shorting. I'm using a breadboard to short the red and black wires. Otherwise, there won't be any flow of current. So let me power it up. Okay, so the LED is working, and a milliampere is working. Now I'm connecting the wire, the circuit, and what I get is 10 milliampere. Okay, I could have tested the voltage, but it's not important. What I want is to increase. This is okay, so I need to turn to the left. Okay, so the left increases the voltage. So I mark this one, okay? Okay, now let me power off, and let's move to testing the voltage. So disconnect here, red to yellow, which is red, black to black. Okay, and it is measuring in millivolts, but now let's connect again. Just a minute. .23 volts. Okay. Okay. Actually, I don't understand what is going on. I think this wire, what is it? This wire. I forgot to mention that the DC to DC buck converters is already set to output 4.2 volts, and now I'm set to measure the resistance, and okay, this is a 10K potentiometer. It's very coarse. You have to use very fine movements, but I don't have a lower potentiometer, and this will do, because it's okay, I can manage with it. So the resistance is going up when I turn it counterclockwise, the same as the red dot shows. So this is fine, and we can disconnect. One last thing that I want to talk about, and it is very important, of course, is this is my back balcony. Yeah, I know it has to be cleaned and taken care of, repaired some, but I have better things to do for now. So I used these building blocks to prepare a place for charging. I will charge over here, and in case of fire I will put it inside here. I have this is sand to pour over and make the fire out, and this is for internal use. I might move the charging indoor, and if I have to carry the battery to this place, I will do it in this one using the gloves. So I think that by now I'm quite ready to start charging.